There was a time when every car on the road was leaking fuel vapor into the air and nobody thought twice about it. There were no computer controls, no containment system, or anything like that. There was no evap system at all as we think about it now. Fuel tanks vented directly into the atmosphere. Carburetors had float bowls that were basically storage devices for the fuel before it goes into the engine. And the float bowls were vented directly into the atmosphere. If they weren't vented, then the pressure building up in the carburetor would push fuel into the engine and flood the engine. As fuel sits, when it gets hot outside, the fuel expands, and fuel is always evaporating, really, no matter the temperature. The hotter it is outside, the quicker it's going to evaporate. So we had a lot of fuel vapors. And with it expanding, if you had a sealed gas tank, then the gas tank may balloon up, much like your lawnmower gas can does in the summertime if it's not vented, like mine. Or, and then that would cause either a fuel leak in the fuel system somewhere, or it's going to flood the carburetor and or flood the engine as well, because that pressure as the vehicle is just sitting there is going to force fuel through the fuel system into the carburetor, into the engine. Then again, when it gets cold outside, the fuel vapors, or the fuel is going to contract, and that could cause the fuel tank to crush a little bit, but it could also pull a vacuum on the fuel system and therefore reduce pressure going to the carburetor, and either the vehicle wouldn't run or it would be starved for fuel. So therefore, there were two ways overall, and I'm really simplifying this, but there were two ways that manufacturers prior to the 1970s took care of this problem. And it was either a vented fuel cap, which would let fuel vapors out, pull fresh air in as needed, depending on the contraction and expansion of the fuel, or they would just have a vent hose connected to the fuel tank somewhere, and then typically ran to the back of the vehicle so you couldn't smell the fuel vapors quite as bad, right? So 1970s came around, a lot of industry, a lot of factories being built, and in a lot of urban areas, there was a huge problem with air pollution and a thing called smog, which consisted of hydrocarbons from raw fuel vapors mixed with oxides of nitrogen, which is a tailpipe emission out of vehicles, and sunlight creates smog. Now, if you've never experienced smog, it is a yellowish, brownish, almost fog, but it's air pollution. And between the 1930s and 1960s, 70s, there are several instances of urban areas that got so overrun with air pollution that it actually caused people to die of not being able to breathe or respiration problems, in the hundreds, sometimes thousands of people in the case of London, England. That's happened a few times in London, actually. So I do have a picture of smog for you to look at. This is from California. Not sure of the time frame here, but this is similar to what smog looks like. It almost looks like fog kind of off in the distance, but you can see it's kind of yellowish, brownish color. And that is smog. Causes lung issues, breathing issues, and stuff like that. So not good. Caused a lot of health problems. So due to that, a lot of countries around the world around the same time frame, late 60s, early 70s, passed Clean Air Acts. Our Clean Air Act was passed, if I'm not mistaken, in the early 1970s, and it was to help clear up some of the air. So the early fuel vapor containment systems still did not have modern electrical controls like our cars now do, but it basically consisted of a vapor canister. And if you've ever popped the hood of your vehicle or looked underneath near the fuel tank, you've seen what looks almost like a coffee can shape, or kind of an oval coffee can shape over near the gas tank somewhere. That is the vapor canister. And what it does is it's filled with activated charcoal. So when the fuel expands, fuel vapors are pushed into the activated charcoal. The activated charcoal will absorb the fuel vapors, the hydrocarbons. And then on the other side of that vapor canister is a vent of some sort with a filter that filters the air out into the atmosphere once the hydrocarbons have been captured. So from there, the vehicle sitting in a parking lot or sitting in your driveway, that's how it worked. The vapor canister was there to store the hydrocarbons. So then when you cranked your vehicle up, there was a hose that ran from the vapor canister to either the intake manifold. In that case, anytime the engine was running, it was pulling fuel vapors in, which would lead to a rough idle. So to alleviate that, they put the vacuum port above the throttle plate of the carburetor, called ported vacuum. Therefore, the only time it would pull the hydrocarbons out of the vapor canister was when you were accelerating. And then that would pull a vacuum in the vapor canister. Fresh air would come into the canister, fill it, hydrocarbons would go into the engine and be burned. So that was one way to do it. Well, another way that manufacturers came up with, and if you are a GM technician in the 1980s, you will know exactly what I'm talking about here. Some manufacturers put a thermostatic vacuum valve on the intake manifold so that it was manifold vacuum that was pulling the fuel vapors in. But because it was a thermostatic valve, this little thing here, then it would only pull the fuel vapors in once the engine warmed up enough to where it would not affect the engine idle when it pulled the hydrocarbons in from the vapor canister. In, I believe it was 1988, which was the year that I graduated from tech school and became a technician, there was a recall on these, and I replaced many of those on vehicles in the late 1980s, early 1990s, because of evaporative emissions. It did not meet federal standards, so they had to replace those. So that's kind of a introduction to the early evaporative emission systems. The limitations of these systems, oh my gosh, if you worked on vehicles in the 70s and 80s, you know the nightmare of vacuum hoses. There were vacuum hoses everywhere under the hood. The problem with rubber vacuum lines is over time, heating, cooling, they would just deteriorate. And that would cause vacuum leaks. That would cause the evap system to not work properly. There was no way to monitor if the hose had a leak somewhere between the fuel tank at the back of the vehicle all the way up to the front of the vehicle. So it wasn't the most efficient way to manage fuel vapors, but it was much better than what we had prior to the 1970s. The canisters would also get saturated. People were filling their tanks all the way up to the top and sit there and just top them all the way off. And depending on the location of the canister, raw fuel would get into the canister, and that pretty much just ruins the canister. It's not able to handle all that as well. Well, then enter the early 1990s. Computers were becoming more of a common thing on vehicles. The early GM quadrajet carburetors had computer controlled carburetors on them, and manufacturers started tinkering with some of that. And because of the technology increase, then the government mandated other pollution control mandates and miles per gallon minimums. So the manufacturers had to come up with new ways of doing things. And then in 1996, if I'm not mistaken, OBD2 became mandated, and it had to be fully implemented by 1998. And part of that was that you had to have a electronic evaporative emissions monitoring system. And here's where we get the purge solenoid, the vent solenoid, the fuel tank pressure sensor, and then leak detection measures that the computer uses to tell if there's a problem in the evaporative emission system. So what happens when the computer monitors this? How does that work? And how does a vehicle detect a really, really small leak in the evaporative emission system? These are very sensitive systems to leaks. And why would a bad purge valve set a fuel tank pressure sensor code? So in the next video, I'm going to show you how modern vehicles don't just control fuel vapors. They also will test and monitor the evaporative emission system almost continually to make sure there's no problems. Thank you for watching this video. I'll be shooting part 2 very soon, as well as doing some case studies that I've had recently on different evap issues. So thank you so much for watching. Please hit that like and subscribe, and I will see you next time. If you have questions, please post them down there in the comments. Thank you very much. I appreciate it. I am Bill, and this was Bill Teaches Automotive Technology. See you next time.